Okay, welcome back to another exciting day in algebra. We are still on Unit 1 and 2, covering expressions and equations, but today we are going to do properties and solving 1 and 2 equations. 2-step equations, sorry. This should be a review for everybody, so I'm probably going to go through it really quickly. Most of the stuff, like I said, most of it's a review. It's also a lot of writing. Sorry, I couldn't avoid it. Definitions. So I'm probably just going to go ahead and read through them. If I'm going too fast, don't forget to pause. I will give like a perfect space to pause if you need to, or you can just pause it at the end once the whole screen's filled up. It's up to you. Okay? Okay, let's go ahead and get started. So, properties. All this stuff should be review for you guys. I'm going to move this off to the side. There we go. So, commutative property. Commutative property means that you are changing the order. Okay? And for addition, we're changing the order of the addends. Addends are the things that are being added together. So, for example, A plus B, that means I can say it's equal to B plus A. They're the same. Okay? When it comes to multiplication, I'm changing the order of the factors. So, A times B is actually equal to B times A. Okay? And then the associative property. Associative property, again, comes in addition and multiplication. So for addition, we're changing the order of the grouping symbols. So we have A plus the group B plus C. We can change what's inside the group, so we can say A plus B, that group, plus C, and they're equal to each other. With multiplication, same thing. We're changing the order of the grouping symbols. So we can say we're going to do B times C first and then multiply by A, or we can do A times B first and then multiply by C. It doesn't matter of the order. So, okay, or change, sorry, it doesn't matter the group. Okay, then we go on to identity. Identity of addition means that if the sum of a real number, so a number, and 0 is that actual number. So A plus 0 is still going to be A. With multiplication, comes to multiplying 1. So the product of a real number and 1 is that same number. A times 1 equals A. Okay? Then we go into our inverse. Inverse property is of addition, again. So it says that the sum of a number and its opposite, meaning opposite sign, is equal to 0. So A plus negative A will equal 0. With multiplication, we did the product of a number and its reciprocal, and it equals 1. So A times 1 over A, the A's cancel out when we cross multiply, and it equals 1. Okay? Distributive property is, where's the thing? A number multiplied with a sum or difference gets multiplied with each added in. So, again, we already did this one, but addition is only over, distributive property is only over addition or subtraction. That's why we don't distribute this A here in a group, because inside they're being multiplied. So only if they're being added or subtracted inside. We go ahead and distribute everything to everything, or A to everything, and that's what we get. Okay? And the last one, multiplicative property of 0. That just says if you a number multiplied with 0 is equal to 0. Okay? So if you missed something, sorry, I don't know why I'm moving up and down. If you missed something, feel free to pause the video, rewind it, make sure you get it all down. This all should be filled in. And yeah, let's go on to the properties of equality. This stuff is probably new to you, okay? So, reflexive property says that a number is equal to itself. Again, these properties are new terms for you, but the logic you already know. Like A is clearly equal to A. Okay? That is known as the reflective property. Think of it like a mirror. If the equal sign is a mirror, A equals A. Okay? Symmetric property says that the order of the equality doesn't matter. So if A is equal to B, then we can say B is also equal to A. And we can have either the A or the B be first. Okay? Transitive property says that two numbers equal to the same number are also equal to each other. That's a really bad wording, but that's what it looks like. If we know that A equals B and that B equals C, then we know A equals C. Okay? Substitution. A number that is equal to an expression can replace the expression. So if we know that if x equals y, then y can be substituted for x in any expression. For example, we know that here the expression 3x, but we know x equals 4. We can plug in the 4 for it. Okay? Same thing, if we know that 3 plus 4 is equal to 7, instead of writing 3 plus 4 every time, we can just put a 7 in there. Okay? Addition of equality says that if you add something to one side of the equation, you must add it to the other side to keep it equal. So if we have x equals y, and we decide to add z to x, we have to add z to y to keep it equal. Subtraction. If you subtract something from one side of the equation, you must subtract the same thing from the other side. So if we have x equals y, and we subtract a z from x, we have to subtract z from y as well to keep it equal. Multiplication. If you multiply something on one side of the equation, you must multiply the other side to keep it equal. So again, if we have x equals y, and we multiply x by z, we have to multiply the y by z to keep it equal. And division of equality. If you divide something on one side of the equation, you must divide the same on the other side to keep it equal. So x equals y, and if you divide x by z, you have to divide the y by z as well to keep it equal. I'm sorry, it's a lot of writing, I know. I'm sorry, I don't know what to tell you, what else to say. I'm sorry. I'm sorry. Sorry. Okay, so now we go on to solving 1- and 2-step equations. To solve an equation, we must isolate the variable. So we got to get that by itself. We do this by undoing the operations in the opposite order of GEMDAS. So instead of doing the grouping first and then all that fun stuff, we actually do the opposite order. So the undoing order is S, A, D, M, E, and G. Spells SADMEG. So again, we undo any subtraction or addition first, whatever's there. Then we undo any division or multiplication. Then we undo any exponents. Then we undo any groups. Okay? SADMEG. You're going to hear it a lot. SADMEG. Meg is sad because you're undoing all her work. So, examples. We have to solve the following equations for the given variables. So, 4 times x equals 1. That's multiplication happening to the x. So to undo it, we divide everything by 4. That's our division property of equality there. So 4x divided by 4 gives us 1x. 1 divided by 4 gives us 1/4. So x equals 1/4. Okay? So here we have 4/5 m equals 28. M is being multiplied by 4/5. So you can divide both sides by 4/5 if you want to. This is what it looks like. 4/5 being multiplied by m and being divided by m, the 4/5 cancel out. Okay? It equals 1. 28 divided by 4/5, you can do this in the calculator as long as you put 4/5 in parentheses. It will give you 35. Okay? So 1m equals 35. M equals 35. But wait! There is another way to do this. Okay? Instead of dividing by 4/5 and having a fraction on top of a fraction, you could use, what's it called? The inverse property to help you. Okay? Because it's already a fraction, you could multiply that fraction by its reciprocal to make it into a 1m. Okay? And this is what it looks like. So 4/5 m times 5/4. When you do 4/5 times 5/4, you get 1. Okay? Again, you can do this multiplication in the calculator. So this will give us 1m equals 35 as well. M equals 35 is our answer. This way is a lot easier, in my opinion, because even in the calculator, it's a lot easier to type it in rather than trying to divide. Okay? Dividing fractions is already a pain in the butt, where multiplying isn't as bad. Okay? So you try to do multiplication if you can. It's a lot faster, easier, less stress, headache, all that fun stuff. Okay? Alright, this one, we got a two-step here. So here, we have to follow SAD/MAIG. So we have multiplication with the R, and we're adding something to that R. So according to SAD/MAIG, we undo the addition first. So I have to subtract 1 from both sides. Okay? And 1 minus 1 will just give me 0. So it just leaves me with 3R. And 16 minus 1 gives me 15. Now I just have multiplication I have to deal with. So I undo that by dividing by 3. So I'm left with 1R equals 5, or just R equals 5. I'm sorry, I meant to do a headphone alert. Alright, and then the last one, here we have a lot of things going on. Okay, X is being, we're subtracting something from X, then we're dividing something. But we're not just dividing the X by 3, we're dividing the entire thing by 3. So that's actually a group. And according to SAD/MAIG, we touch this group last. Okay? So we have to undo the division before we touch the group. So we go ahead and divide everything by 3. Oh, I'm sorry, not divide. We already are dividing. Multiply everything by 3. When you divide this group by 3 and multiply it by 3, they cancel out. So here we get negative 36. And over here, oh, I skipped a step, sorry. We get x minus 7. Now we can undo this minus 7 by adding 7 to both sides. So we get x equals negative 29. Okay? That was a very quick overview. So go ahead and try these on your own. We will go over the answers next class. Okay? But do give all of these a try. Okay? I want to see some work from these. It's okay if you don't get the right answer. We will go over them in class. But you have to try in order to get something. Okay? And if you have something, then you have something to work with. Alright. You try those on your own. Pause the video. Work on them. When you come back, we'll move on. Okay. So hopefully you tried these. Let's go ahead and move on. Oh, yeah, we do step builder notation. Sorry, a teacher asked if we did this, and we do. So step builder notation is basically a way of writing your answer. So we have x, a line, x equals our answer. Okay, and it's in these little braces again. This is how it's read. The set of x is such that, so such that is that little line. Little braces mean sets. Such that x equals whatever the number. Okay? So, we have to put our answers from example 1 in step builder notation. So these were the answers. Or to write these, all you're doing is writing the answer and then putting a line in front of it, the variable in front of it, and putting braces around it. That's it. So here, we got, that's our answer in step builder notation. Okay? That's it. B, it's a set of m such that m equals 35. C, the set of r such that r equals 5. And I bet you probably already did this because I'm going very, very slow and I don't know why. But it's a set of x such that x equals negative 29. Okay? So for your try on your own, you're going to try to write down the answers you got for your first try on your own in step builder notation. Okay? So go ahead and give that a try. That's it for this page? Cool. Give that a try. When you come back, we'll move on to our next thing, and we'll go over these answers next class. Okay. Last thing, identifying properties. Sorry, again, it looks absolutely horrible, but I did most of the writing for you, so it's okay. So we're identifying properties. So this is an actual SOL kind of question where they're going to give you all this work and be like, what happened here? Okay? This will also be on your second quiz. I know it's a question on your second quiz. So for this thing, we're going through and we're just trying to figure out the problem. So this one, we have our original problem. Now, from 74 equals 8 plus 3v to this line, what did we do? Well, we subtracted 8 on both sides, and we have a minus 8 on both sides now. So that's our subtraction property of equality. Okay? Then, the difference between this line and the next line is that the negative 8 actually moved closer to the 8. That's the only thing that happened, is that we changed the order. So that's our communication property of addition. And you do have to write of addition or multiplication. Okay? Then what we did is the 74 minus 8 we got, it became a 66. That's technically substitution. Okay? But the bigger thing that I'd like you to focus on is what happened here. 8 minus 8 became 0. Okay? That's the inverse property of addition, where a number plus, remember, minus means plus the negative, so a number plus its opposite number gives you 0. Okay? Then we went ahead and we have 0 plus 3v, and it just became 3v. That was the identity property of addition. So a number plus like a 0 plus a number gives you that same number. Okay? Then we went ahead and divided both sides by 3, which is our division property of equality. And then we did that. That's actually supposed to have inverse property. This should actually say inverse property of addition or multiplication, because we divided. And yeah, I'll explain more about this in class. It's not as complicated as you think it's coming across, but okay. So I want you to go ahead and try these on your own. This one's not right, but I can't seem to get rid of it. So go ahead and try these on your own. We'll go over the answers. Okay? And that's it for notes. Cool. If you have any questions, make sure you make notes of them and we can go over them in class. But other than that, have a great day. Enjoy math. I'll see you next class. Bye.